Okay, here is practice quest number 2 for 6-1 to 6-3. So again, the directions say round to the nearest hundredth when rounding is necessary. So first problem says point M is 4-3, point N is 2-1. Find the coordinates of vector Mn. All right, you've done this a million times. You know how to do this. 4 to 2 is -2. 3 to 1 is another -2. So the coordinates of that vector are -2, -2. 2 minus 4, 1 minus 3. Now we've been given a couple of vectors here. And we're going to do some stuff with them. So this is the given. So using those, problem 2a says find v minus u. Now, v minus u will be 4-3 minus 2, -1. So when we add or subtract vectors, we just do x minus x, y minus y. So 4 minus 2 and 3 minus -1. Be careful, 3 minus -1. So the coordinates of v minus u are 2, 4. Problem B is the same, v plus u. We're adding now. So we're going to add 4-3 and 2, -1. So adding those is going to give us 6-2. 4 plus 2 is 6. 3 minus 1 is 3 plus -1 is 2. So that is v plus u. That's problem B. Now C is a little bit bigger. C says we need to find the magnitude of 2v minus 3u. So we're going to do magnitude last. We're going to work on this part in here first. So 2v would be 8, 6. 2 times v, 2 times those, each of those, 8, 6, minus 3u would be this. 3 times 2 is 6, 3 times -1 is -3. So we are subtracting 2 v's minus 3 u's. All right, so now we'll do the subtraction. So 8 minus 6 is 2, and 6 minus -3, 6 minus -3 is 9. So the coordinates of all this stuff here, 2v minus 3u, all that works out to be 2, 9. Now we need the magnitude. To find magnitude, we square the first one, square the second one, add them up, and take the square root. So the answer to question C, there's a lot of work there, easy work, but a lot of it. The answer to question C is the square root of 85. Now D says v dot u. V dot u. So we're taking 4-3 and we're dotting it with 2, -1. And when we do a dot product, we take the x times the x, the y times the y, and we add them up. So 4 times 2, 3 times -1, and add them up. So 8 minus 3, that dot product is 5. So the answer to question D is just 5. All right. E says we're going to do v plus 4u. Okay. So we're going to take 4-3 and add 4 of these, which would be 8, negative 4. 4 u's, 4 times 2, 4 times negative 1. We're going to add those together. X plus x, y plus y. And there's your answer, 12, negative 1. And then the last one, this is question F. What is the magnitude? Remember, this means magnitude. What is the magnitude of u? Well, to find magnitude, we square the first one. We're doing u. Square the first one, square the second one, add them together, and take the square root. So the magnitude of vector u is simply the square root of 5. Okay, so now we're ready. That was all question 2. So now we're ready for question 3, which is a really easy one. It says we got a couple of points, and we are going to find the components and magnitude of AB. So there's the components right there, vector AB from A to B. 3 to 4 is 1. 1 to 7 is 6. So the components of that vector are 1, 6. Or you could do 4 minus 3, 7 minus 1. So there are the components. Components just mean like the ordered pair that represents the motion of the vector, the movement of the vector. Now the magnitude, square the first one, square the second one, add them together, and take the square root. So the magnitude is the square root of 37. Okay. Now the next one, we need to find the components again. So we're looking for this again, but this time we have a picture. We're not starting with ordered pairs, we're starting with a picture. So here's the scenario. The vector is 10 units long, and its direction angle is 207 degrees. And we are going to come up with x and y. Now, as I mentioned in the last practice test, there is more than one way to do this problem, but I want to stay consistent with how we have been doing it all along. So I'm going to go ahead and drop a perpendicular to the x-axis, making a piece of my butterfly bow tie, and recognizing that this is my x and this is my y. Now that's easy. We're going to use SOHCAHTOA, straight SOHCAHTOA trigonometry here to do this, but I do want you to notice that x and y are both going to be negative. Pay attention, left and down. So we are going to be negative on both of those. So I'm going to go ahead and mark that now so that I don't forget. Also, I need to know what this little angle is right here. If I'm going to be doing my trigonometry, I need to know how big that angle is right there, inside the triangle there at the origin. So that's easy to figure. I know that the whole thing is 207, but I know this much of it, look where I'm pointing, this much of it is 180. So doesn't this have to be 27? It's 27 degrees past 180. That's how we get 207. 207 minus 180. So now I can set up my equations. I know cosine 27 equals x over 10, and sine 27 equals y over 10. Remember, cosine always goes with x because it's always adjacent. Sine always goes with y because it's always opposite. Then we'll multiply 10 cosine 27, and that'll give me my x, and 10 sine 27, that'll give me my y. So here we go. 10 cosine 27, 10 sine 27. So my x is 8.91. Now I already marked it negative, so it's negative 8.91. And 4.54 for my y's, and it too is negative. Okay, page 1 done already. All right. Anytime the problem says components, you know you're looking for x and y. All right, now I've got a couple of vectors. This is problem 5. I've got a couple of vectors, v and u. And I am going to find the angle between them. Now, this is where you got to remember your little formula. Hopefully you have this written down, that the cosine of the angle between them, we're calling theta the angle between them, the cosine of the angle between them is their dot product divided by their two magnitudes times each other. So dot product divided by magnitude times magnitude. All right, so all we need to do, it's going to be easy. We just need to figure all that stuff out. So the dot product, again, is x minus x, y minus y. I'm going back to my vectors, x times, did I say minus? I meant multiply. X times x, y times y. So x times x, y times y, add them up. So to find the dot product, we do negative 2 times 5, 4 times 1, and add them up. So we get negative 10 plus 4, so the dot product is negative 6. Negative 10 plus 4. And now the magnitudes of the individual vectors, that's easy. Square the first one, I'm doing v, square the first one, square the second one, add them together and take the square root. Now you don't want to simplify that. It's not going to impact your answer. It's just going to make it harder for you later. So just leave it be. Just leave it alone. Square root of 20. That is not our answer. That doesn't go in an answer blank. That's just the first part of this right here. Now we need the magnitude of u. So we'll square the first one, square the second one, add them up and take the square root. So that's root 26. So we've got our two magnitudes down there. And then you remember what I always suggest you do at this point? At this point, let's go ahead and multiply those two things together. So instead of having two separate radicals down there, we only have one. So the square root of 20 times the square root of 26 will be the square root of 520. Now remember, that is not the answer. Don't write that down. That is the cosine of the answer. So to get the answer, you're going to second cosine that fraction. So when we second cosine negative 6 divided by the square root of 520, we get 105.26. degrees. So the answer to the question is 105.26 degrees. That is the measure of the angle between these two vectors. These two vectors, if we drew them, look like something like this, and that's the angle that you just found, the angle between them. Okay. Now we've got a couple of parametric equations. And these directions are the same as the last time. It says remove the parameter. I like the word eliminate better, because if I tell you to eliminate the parameter, t is the parameter. If I use the word eliminate instead of remove, then you maybe we'll think about using elimination. We need to eliminate those t's. So let's multiply the bottom row by 4. So we have our top equation, and now our new bottom equation, which is 4y equals 20 plus 4t. Let's add them together. The t's, the parameter, will be eliminated, and we'll have x plus 4y equal to 22. And that, my friends, is the answer to the question. That is the one equation that represents these two parametric equations. Remember, when you add them straight down to eliminate the parameter there, the t's are gone. You can't do anything here, so it's x plus 4y. You are adding x plus 4y, 2 plus 20, 22. And that's it. Okay. Now, this one we're sort of doing the same thing but backwards, because we want to end up with x equals and y equals. That's what we want to end up with as our answer. Notice in the little answer blanks there, I even wrote that down. That's what we want to end up with. Okay? So remember, again, this is where good note-taking matters. You want to start with this format. So you got 3 parentheses, and you're going to plug stuff in. And the first one always is just x, y. That's easy. The second one is always just one of these points. So pick whichever one you want. I'm going to use 3, 4. If you want your answer to look exactly like mine, then pick 3, 4. If you don't care if you match my answer exactly, you can use 2, -1. There's more than one form of the correct answer to this problem. Now, in this second or last parentheses here goes the slope or the direction vector. You can think of it either way. All of you are very familiar with slope. You can all calculate slope. So I'll just use that notion. That's the slope. So if I were finding the slope here, I would do 4 minus -1, y minus y, over 3 minus 2. Y minus y, x minus x. So my slope would be 5 over 1. Now, the only thing tricky about doing this is you've got to remember that slope is y over x. So when you translate this into your parentheses, 1 is x and 5 is y. They have to go in that order. 5 is y, 1 is x. Now, I think I told you before, when I do these, I just put my direction vector over there. So 2 to 3, that's a 1, and -1 to 4, that's a 5. So you can do that too if you are uncomfortable or don't want to mess with slope. Either way is fine. This is the slope or the direction vector from the first point to the second point. Okay, well, once you have all that, then it's easy. We're going to write our 2 separate equations. We're going to start by looking at the first part of every parentheses. So x equals 3 plus 1t. And then the second part of every parentheses, y equals 4 plus 5t. And there are the parametric equations of the line through those 2 points. All right, one more on this page, problem number 8. We want to find the components of the velocity vector for an airplane flying at a speed of 410 miles an hour on a course of 218. All right, let's draw a picture of this first. Remember, it's a navigation problem. So in our navigation problems, we have to use our compass. So here's our compass. And a course of 218 would be down here somewhere. Don't worry about getting it exactly right. Just get it in the right quadrant. That's 218 degrees. Past 180, not all the way to 270, so in there somewhere. And its magnitude is 410. As is always the case, always, 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 we're going to butterfly bow tie it. This is your X and this is your Y, and that's what you're looking for. Notice it says find the components. So the components are the X and the Y. You might also, while we're sitting here, notice that they're both going to be negative. Why are they negative? Well, you're in quadrant 3. That angle is in quadrant 3. So you're going left and down to draw this vector. You go left and down. So X and Y are both negative. In order to answer the question, we know what we're going to do. We're going to use cosine and sine. But in order to do that, we need to know how big this angle is right here. We need to know the angle inside the triangle. Kids, I'm not interested in this one. I don't care what this one is. It's not in my triangle. I need this one right here. I need the one that's in the triangle. So if I know this far is 218, and I know all the way to here is 270, because that's how it's labeled. This is 218. This is 270. Then I need to figure out how far apart 218 and 270 are. So I'll just subtract 270 minus 218, and that angle is 52 degrees. 218 plus 52 would bring me to 270. So now I can do my equations. So I know cosine 52 equals x over 410, and sine 52 equals y over 410. Remember, cosine is always adjacent, x, sine is always opposite, y. So to find my x and y, I'm going to multiply my 410 over there. So I'm going to do 410 cosine 52, and that's 252.42. And I've already marked it negative. And then I'll do 410 sine 52, 323.08. And it too is already marked negative. Okay. Anytime the problem says find components, this is what you're looking for. You want to have an answer that looks like that, an X and a Y. All right, one page to go. First thing, number 9 says we have a vector, negative 3, 4. Find a unit vector for this. Now, remember, we've done a lot of these. Your unit vector is just going to be negative 3, 4, these coordinates, divided by the magnitude of the vector. So we're going to take the coordinates of the vector, negative 3, 4, and divide each one of them by the magnitude. So the magnitude would be square the first one, square the second one, add them together, and take the square root. Well, that works out to be 5. So the magnitude of this vector is 5. So the unit vector is negative 3 divided by 5 and 4 divided by 5. That is your answer to the problem. Hopefully you've taken good notes, and remember that to find a unit vector, we simply take the coordinates of the original and divide each one by the magnitude of the vector. So our magnitude worked out to be 5, so there is our unit vector. All right, we got some random vector here, and we're going to find its magnitude and its direction angle. Magnitude's a no-brainer. We just did it. Square the first one, square the second one, add them together, and take the square root. So the magnitude of that vector is √5. Now the direction angle is going to be a little trickier because we're going to have to draw a picture of it. So -2, 1 is going to look like this. There it is. This is my actual direction angle right here. The purple thing is my direction angle. But I can't really find that right off the bat. I'm going to have to drop a perpendicular. This is 2 and this is 1. That's how I plotted the point. Left 2, up 1. And I'm going to find this angle first. Now, keeping in mind that that's opposite and that's adjacent, we're going to say the tangent of that red angle is 1/2. The tangent of the angle is opposite over adjacent, which means that the angle will be second tangent 1/2. Anytime we have our function hooked to our variable, to solve for the variable, you have to do second. So we're going to second tangent 1/2. And the red angle is 26.57. Now remember, the red angle is not the answer to the question. The purple angle is the answer to the question. So, how can we find the purple angle? Let's use our logic. If we came all the way to here, all the way to this black line, that would be 180. But we stopped before we got to 180. We stopped 26 degrees before we got to 180. So to find that purple angle, we'll do 180 minus 26.57. So your direction angle is 153.43 degrees. That is the answer to the question. That is the direction angle. The purple angle. The angle in standard position. That means it starts on the positive x-axis. All right, in number 11, we got a couple of vectors. And we want to know if they're parallel, orthogonal, perpendicular, or neither. Okay? So there's a couple different ways you can do this, but one way is just to find the slope of each vector. And that's easy because slope is rise over run, it's y over x. So the slope would be 1 over -2. Remember, if you draw a picture of this guy, you're going left 2 and up 1. So left 2 and up 1. That's a slope of 1 over -2. This slope would be y over x. The slope would be 2/4, which is positive 1/2, y over x. Now wait a minute, don't be tricked. These are neither. In order to be parallel, they have to be exactly the same, and they aren't. In order to be orthogonal, perpendicular, they have to be opposite reciprocals. So I've got one positive and one negative. That's good. That's opposite. But they aren't reciprocals of each other. So therefore, these two vectors do not have a relationship, a special relationship. And finally, we got a bunch of points. So we have 3, 6, and 1, -2. And we have 5, 4, and 3, 12. And we want to know if AB is equal to CD. Well, that's an easy question, because if they're going to be equal, then they have to have the same coordinates. So let's find the coordinates of each of these vectors, and if they match, then we're equal. If they don't match, then we aren't equal. So here we go. 3 to 1 is -2. 6 to -2 is -8. It's easier for you, do 1 minus 3 and -2 minus 6. Here are the coordinates of vector AB. Okay, now we're going to do CD. 5 to 3 is -2. 4 to 12 is +8. Or 3 minus 5, 12 minus 4. Are these two vectors equal to each other? No. Why not? Because their coordinates aren't the same. So you answer the question by saying no, they aren't equal because their coordinates don't match. The coordinates have to be exactly the same for these vectors to be equal. All right, that's it. Good job.